Everybody, it's Dr. Bardo again. I'm going to show you how to do digital hourglass uh, tonight. Just to give you a quick reminder of what that means, we're going to have a bunch of LEDs and we're going to have a tilt sensor. And I want every 10 seconds, I want one more of my LEDs to light up. So we'll wait here a second while we get to 10 seconds so you can see this first LED light up after 10 seconds. There we go. And if you run the tilt sensor back and forth, it resets the thing. Okay, so this is what I want it to do. Now let's make it do that. So I'm going to start a brand new Tinkercad. So I'm going to create a new circuit. Bring over my Arduino and sort of put it in the rotation that I like, the orientation that I like. Okay, first thing I want to do is make sure I get my tilt sensor working. So let me first find my tilt sensor. If you scroll through here, you won't see it. Oops. If you scroll through here, you won't see a tilt sensor. So let's just search for one by typing tilt in the search thing. There's a 4-pin tilt sensor, which you have to rotate to make it fit. So the little notch should be on the left-hand side. Okay. Of course, every project is going to have a power and ground wire. We do it so often, sometimes it's easy to forget. And I'm going to turn those to their standard colors. I think maybe I'll move my tilt sensor down just a little bit. Okay, very much like a button, I want to bring power to my tilt sensor, and it doesn't matter which way I do that. And I want to connect my tilt sensor to ground as well. Very much like a button, I want to have a fairly large resistor here, a 10 kilo ohm resistor, so that I force most of the electricity to go to the Arduino. Okay, and then I'll connect that. I'm going to connect it to pin 8, actually, the sensing one. So let's write a little bit of code to make sure that my tilt sensor is working. As I add components, I want to write some code that makes sure that they work. Okay, so I'm going to have a variable, which is going to be an int that I'm going to call tilt. I'm going to start it being 1 because tilt sensors have electricity flowing through them initially unless you tilt them. So unlike a button, which is normally breaking the circuit, a tilt sensor normally completes the circuit, and then the interesting happens when you tilt it and it breaks the circuit. So I'm going to put in a variable called tilt, which is going to be equal to 1 to start with. I'm going to make the pin mode of 8 be an input. And because I want to test a sensor, I'm going to use my serial port to just check that to make sure that it's working. And oops, that's exciting. Delete the stuff that's here. And then say tilt equals digital read 8. That's where the tilt sensor is, and serial print ln the value of tilt, and give a little delay so I can see what's going on. Okay, so just that code there should be enough for me to test if my tilt sensor is working. So I'm going to start my simulation. I'm going to open my serial monitor. I can see all of those ones. Those are ones are being repeated over and over again. And I push on my tilt sensor. I tilt it, and now I get 0, 0 because it's tilted. I tilt it back, and now I get 1. Okay, so my tilt sensor is working. Great. Now I'm going to put in 6 LEDs, 6 red LEDs. Get rid of my code here. Get an LED and put it here. Now I'm going to copy and paste that LED and put another one there. Copy and paste an LED, put another one there. Copy, paste, copy, paste, copy, paste. And there's my 6 LEDs. I'll get a resistor, which I'll connect to the ground. I'll make it a 220 resistor. And then once I've done that, I'll select the resistor, copy and paste it, and be sure to paste it on the cathode side to the ground. Now I'm going to wire up pin 7 to the top LED and just keep picking a lower LED. I don't have to color these wires yellow. I like to code my output wires yellow and my input wires green. I think that helps me sometimes. A little bit more on the pins I'm choosing to use here. The pins 0 and 1 are sometimes used for serial communication. So if you're using a serial port, 0 and 1 can sometimes be kind of crazy. So most of the time you want to stay away from using pins 0 and 1. All right, let's write a little bit of code now to test my LEDs and just make sure that they're working. So I want to pin mode all of these LEDs, and there's a lot of them. So I'm going to show you a shortcut to doing this called a for loop. Okay, so I'm going to pin mode my LEDs here. And so a for loop is something you would do when you know how many times you want to loop through something. So I want to loop through 6 times, and each pin is something, it starts at the smallest one is 2, the largest one is 7, so I'm going to say that's less than 8. And every time I go through my loop, I want to do the next pin. So I'm going to start at 2, and then do 3, and then do 4, and then do 5, and then do 6, and then do 7, and then I'll stop. So what am I going to do each time? So I'm putting a little brace here to show that I'm going to have a list of instructions that happen each time. I'm going to pin mode whatever I is now and make it an output. And that's all I really need to do right now for that. But it occurs to me I can use this same kind of code to create a nice test of whether my LEDs are working. I'm going to use my for loop to say digital write I and then high. So that's going to turn on all my lights, because it's going to turn on light at 2, then the light at 3, then the light at 4, then the light at 5, then the light at 6, then the light at 7, and then that's it. Okay, so this is some nice code just to make sure that my wiring is working. So let me start the simulation, and all my lights light up, and I feel good. All right, all the wiring is good. I'm ready to do my code. The code here has to do with time. We're going to measure time with something called millis. Millis is how long the Arduino has been working through its program in milliseconds. So it's kind of the watch for the Arduino. We're going to need some variables though. So let's go ahead and dig in to some more variables. We're going to have something called an unsigned, which really means that it can only be positive. Long, which means that it might be a really big integer, and it's a variable that we're going to call the previous time. So this is what millisecond the last time it got we lit up an LED. Okay, and when was the last time we lit up an LED right at the start? Well, we never at 0. We're saying that's the moment we want to measure from time 0. Okay. We're going to have an int for the next LED to light up. And the next LED to light up is going to be 2, the one that's on pin 2, because that's the first one we're going to light up. We're going to have another long integer called the interval, which is how many milliseconds it is between the LEDs lighting up. That's 10,000. So previous time is the last time I lit up an LED. Next LED tells me which pin I should use to light up the next LED. And interval tells me how long it is between LEDs lighting up. Okay. The setup is all good. We've set up all the channels for communication with our various components. We're all good. We're just going to look in the loop. All right, in the loop, the very first thing we're going to do is get another unsigned long, which we're going to call current time. And it's going to be whatever the clock of the Arduino is saying. So we are going to ask millis, what time is it now? That's the current time. And what are we interested in? We're interested in how much time has passed compared to the last time we lit an LED. So we're interested, how much time has passed? What's the difference from the current time and the previous time? If it's been more than 10 seconds, which is my interval, then what should happen? Well, a couple things. I should digital write the next LED to be on. And I should make the next LED be 1 bigger than it used to be. So if it was 2, it should be now 3. Makes sense. Okay. All right. And that should be fine, except what happens if I've lit up all the LEDs? Well, how would I know that I've lit up all the LEDs? Well, so not that yet, sorry. If next LED is is 9, then I want to turn off all the LEDs and start over. So that's going to be just another for loop. Except I'm not going to turn them on, I'm going to turn them off. And one more thing I want to do is I want to make the next LED equal to 2. I want to go back and start lighting up from the bottom again. Okay? And that's what would happen if it was time to flip over the next one. But I need to worry about the tilt sensor. So let's figure out what the tilt is doing. Okay, well, I've got that code already here. If the tilt, so we should say if the tilt sensor equals, well, what would it be if it got tilted? It would be low. And what should we do? Well, we should do the stuff that we did up here. We should turn all these things off and make the next LED equal to 2. And that's what we need to do. We don't need this delay anymore. Okay, so let me put in some code here, just to some comments, just to help you understand what each thing does. This finds the current time. This asks if it has been more than 10 seconds. This lights the next LED. This sets the next LED to be 1 bigger. Okay. If they have all been lit, then make them off and reset next LED. Okay, here we find out what the tilt is saying. If tilted, turn off LEDs and restart the list of LEDs to light up. All right, one thing I forgot. One thing I forgot, this is very important. If we've gone more than 10 seconds, then my previous time is too far back in the past. And I should reset my previous time to be the current time, so that we can be measuring from this new moment in time. And one more thing. It seems like I could I could let next LED be 8. If we look at my wiring, I don't want to let it be 8. Okay? So I'm going to just put in here a little if statement. If next LED is less than 8, then I can light it. I do this so that we are able to light that last LED and hold it for 10 seconds. We want that last LED to be lit. If we don't have this if statement, I encourage you to try this. If you take that if statement out and run it without that, you'll see that the last LED is only lit for 1 little millisecond, and then everything resets. So let's take a look at the code, and I'm going to make one change just to make it run faster for us. I'm going to have it light up every second, so that we're not waiting watching this, okay? So let's start the simulation. I made a boo-boo. Uh-oh. Let's look and see what it was. Okay, so it says down here in line 26, expected a semicolon before if. So I forgot to put a semicolon right there. So I'm going to put that semicolon in. Okay, I said it happens to everybody. Okay. Here's my simulation. Here's the first second, and the first one lit up. Second millisecond, second one lit up. Then the third one. Then the fourth one. Fifth one. Sixth one, and it stays on. I want it to be on. And then when we get to 7, they should all go blank, which they do. And we'll just make sure that the tilt sensor is working here. So when I tilt this back, it should reset. Okay, and then start up again once it's in there. Hope this helps. Feel free to ask me questions. Feel free to there's the homework tonight to tell me what you like best in the class. If you have questions about this, let me know. For loops are a really important thing. Really think about what's going on there. That we start at some number, that we go up to something, and that we increment every time. Have a great night.